Hi everyone, welcome to this new tutorial. Today I'll teach you how to use React for game development. So React is a library, quote unquote a library because it's mostly a framework in practice, used to build UIs for web applications. And in today's tutorial, I'll teach you how to use it for your JavaScript games. So for building the UI of your JavaScript games. So here I have a simple project setup here with a character that moves around. And then when I talk to the NPC, we have a text box that appears that is written made with React. So here we go. And the whole point of this tutorial is to teach you how to integrate a game that is made using JavaScript, using the HTML canvas with the React-based UI. So to understand how it is possible to achieve something like this, I need to do some diagramming, so draw some stuff. So the technology stack we're going to use for this tutorial is first we're going to have a Kepler, which is a library for making games in JavaScript using the HTML canvas element, which is where we display most of our game's graphics. So this is our first component, Kepler. Then the second component of our stack is a technology called, well, first it is React. So React, which is what we're going to use for UIs. So by the way, as I mentioned here, it's just an example of using React for text boxes, but you could use them for on-screen controls. Let's say you want to make a mobile game. So these are all options you can explore. And since React is really made for UIs, you can achieve great UIs very quickly with it. So it might be very worth it, your time to integrate React to a JavaScript-based HTML canvas game. So the second piece of technology is React.js of our stack, which is a library, as I said, for making UIs. Then the third part of our stack is a library called Jotai. So Jotai is a state management library, and it's a crucial component of our stack here. So here is how it looks like with the mascot, etc. And it's very easy to use state management, React state management library. It allows us specifically in this context to communicate between our vanilla JavaScript that is used to draw the graphics and make our games in Kepler and the React layer, the React UI layer. So if I go back to my diagram, so this is the third part, which acts as the bridge between Kepler and React.js. By the way, if you don't know Kepler, if you don't know Jotai, or if you don't know really React, you can still watch this tutorial because I'm gonna explain everything. So here we go. So Jotai acts as the glue between the HTML canvas Kepler game. Here you could swap it to any other technology you want to use, even the HTML canvas API, the canvas API, you could use it. And yeah, so that's the glue. And finally, the last part of the stack, which I think adds a lot to using React as a UI for our games, is Framer Motion, which is a library for making animations in React. So you can see here in our demo example, when the text box opens, well, this smooth transition animation is made with Framer Motion. And you could imagine if you were to make a game with more complex UIs, it would come in handy to have all of these animations you can easily implement. All right, so that's the stack. Those are the 4 technologies we're going to use. So I would suggest we just jump right into the project and code. So what we're going to need here is I have an empty folder called Kepler React Tutorial. Feel free to name it however you'd like. I'm using VS Code here because this is just the tool I like to use for my code editor. It doesn't really matter. So I'm going to use Vite, which is the node module bundler for using front-end libraries like React very easily, and not just React, but also for installing libraries from npm, the package manager. If you're more of a beginner, I have a beginner tutorial on how to learn JavaScript to make games on my channel, so feel free to check that first. So here, npm install npm, sorry, create vite. So my terminal is kind of weird here. So I'm just gonna, do a, what was the command? I don't remember. Anyway, I'm gonna type npm create vite at latest and then dot, so that the project boilerplate is created within the current folder I'm in. So if I do this, I'm gonna have a bunch of options. I'm gonna select React for this project and JavaScript. So now that this is done, I'm gonna install my libraries. I'm gonna install very specific versions. So I'm gonna do npm install. First of all, we're gonna install Kepler, and the reason I'm pinning those versions, I'm writing specific versions, is so that if you're following this tutorial in the future, if you follow and put the exact same dependencies, you should hopefully have something that works in the end. So what I would recommend if you're watching this very far into the future is to just, follow the tutorial with the versions I'm currently having here, and then you can experiment on your own trying to update to the latest versions of each of those libraries. So here, Kepler at version 4000.0 dot 0 dash alpha dash 10. Okay, there's a bit of explaining to do here. The reason it's called Kepler 4000 is because Kepler, the JavaScript library for making games very quickly, works in thousands. So version 3000 is kind of version 3, and version 4000 is version 4. I'm using version 4000 alpha 10 because it's the most recent version available. So just as a way to future-proof this tutorial as much as possible. The second library I'm going to install is Jotai. So I'm going to use Jotai at, and then the version is 2.10.1. So now this should also work. Then, of course, we're going to have to install React and React DOM. So React is the actual React library, and React DOM is what allows us to use React for the web. I'm just going to use simple terminology like that. So 18.3.1. By the way, even though, whoops, I forgot to do npm install React at 18.3.1. One thing I forgot to mention is that even though I'm going to explain everything, it's not a beginner React tutorial. I would recommend that you watch something specific on React if you're not familiar with React. You can still follow along, and hopefully you're going to understand a lot of concepts here for React. I'm going to explain if there is the need to. So now that we have npm installed React, we are also going to install React DOM. So React DOM is going to be version 18.3.1 as well. And I think we're ready. So now I'm going to open up my files, and I'm going to delete, you know what? I'm going to delete this, the asset folder for now. Let's delete that. Here for the app.jsx, I'm going to remove everything. I'm going to fill that later. Main, we're going to keep that. We're going to add to it. Index.css, we're going to remove everything in it, and I'm going to replace it with other things later on. And then here in our vite.config.js, I'm going to, you know what, it's not important for now. Here. So now we have our project set up. We're going to go to the index.html, and instead of using the div as the root, with the ID root, I'm going to set it as the ID UI. So just to have a clean separation that whatever goes into this div is the actual React UI. And I'm going to create on top here. So maybe I should increase my font size even more maybe. All right. I'm going to create a canvas element. I'm going to have an ID of game. So now what I'm going to do is to go to the main.jsx, and in main.jsx, you see you have app.jsx. What I'm going to do is create, instead of app.jsx, I'm going to rename this file to React UI. It's going to be the entry point of our React UI. I'm going to declare my React component. So a component in React is basically a function. So export default You don't have to default export it, but a function that has a name, and then it returns some GSX, yeah. And what it is it's a basically HTML but written in JavaScript. And Vite, our module bundler, will be able to bundle this code into pure JavaScript that will run in the browser, because you know GSX by default does not work in the browser. It's an extension to the language. It's not actually supported by browsers. So here I have a div, and for now let's leave it empty. Let's look at our folder structure. By the way, I have a few assets to bring in. So those assets are going to be linked in the description. So we're going to have two things maybe. Yeah, two things. Actually three, because we're also going to have a font. All right, so I added the background image, which is just going to act as our background. Nothing fancy here. Character.png, which is our player character, and also the NPC we're going to talk to. Gameboy.tdf, which is our font. So this is all the assets you need for this tutorial. All right, so now let's go and continue scaffolding our project with the folder structure. So for the folder structure, what I'm gonna do is create a folder called React Components. And yeah, I'm just gonna leave it like that. We have index.css. I'm gonna create a outside in the source a init game.js, which is going to be a file that is going to run the logic to start our game, our Caplay game. I'm going to explain the Caplay specific concepts in the moment. So here I'm going to also create a Caplay CTX, stands for Caplay context. It's a way to import Caplay in a way that is going to be more maintainable and clean. We're going to also create a store.js file. The store.js is where we're going to do our state management, and it's where we're going to set up our various state variables from Jotai that we're going to be able to use in both the vanilla JavaScript portion of this project, which is using Caplay, and the React-based UI. So I think we have everything we need. And yep, we have everything we need, and we are ready to start creating our various files. So I'm going to start with the Caplay context. So for the Caplay context, I'm going to import Caplay from Caplay. Then I'm going to export default function and create a function called init Caplay, which will create our Caplay context from which we can use all Caplay related functions. If you're not new to the channel, you will find this very strange, because usually I just immediately create the Caplay context here and just import the constant as the context. But for this purpose, for this specific case where we use a React layer on top, you might not want to do that in a case where you have a menu, for example, with many options, and then depending on those options, then you create the game, then you go to the game, and then etc. So for that case, what I opted to do is to create a function that is going to create the context and return it, and then we just use that same context everywhere by passing it as a param to every function. So here, to create a Caplay context, and creating a Caplay context can be seen as initializing our canvas. So you do here, I'm going to return that context, which is returned by a function called Caplay, which is the default Caplay, the import here. This is how you initialize the Caplay context, and you can pass in an object with a bunch of params which are specific to your game. So here you can set the width of your canvas with, I will go with 1920 by, height of 1080. And then letterbox is going to be true. So letterbox allows the Caplay canvas to scale regardless of the screen size while maintaining this 1920 by 1080 aspect ratio, which is usually what you want in desktop games. So here it's really focused on building a UI on top of a desktop experience. So something that will always remain in the same aspect ratio, but can scale depending on the device. So you could also have this on mobile in landscape mode, for example. So here I'm gonna set the global property to being false. This makes sure that we cannot call Kepler functions from globally, because by default you could do that. You could call Kepler function globally without using this Kepler name here. And this is very handy when you want to quickly prototype stuff, but it can really lead to a messy code base. Well, it depends on how you use it. Yeah, I'm sure you can find a way to have it clean and easy to manage if you're good. I'm going to set the debug mode to being true. By default, it is set to true, but I prefer to explicitly set it up to true so I can remember to deactivate it in prod. So put back to false in prod. And here I can set a debug key. By default, it is F1, but depending on your browser, F1 might not be the key, or if you're on Mac OS. So here you can specify whatever key you want. I want to remain with F1 for this project. So feel free to change this debug key to whatever you see fit. Now I'm gonna set the canvas property to being the canvas we created in the HTML file, the index.html. So here it's going to be the game. So I'm going to get the game canvas. So if you go to index.html, you see we created a canvas element with the ID of game. So I can just bring that back here by using getElement by ID. And then finally, I'm going to set the pixel density to being the device pixel ratio. So this is useful so that your game graphics are sharp on any screen. So I have a big monitor here currently, and if I don't use this, the graphics are a little bit blurry. So that's why if you use your device pixel ratio, which this is something in vanilla JavaScript, it's supposed to, being provided by the browser. So depending on the device, it's going to adapt. So yeah. All right, so I have my init function. So let's go to our init file. So in init I'm going to first import init and right below, I'm going to export a default function that is going to initialize our game. So init is just going to contain all the logic for our game. There are many features of Kepler that I'm not going to use in this tutorial. So if you're curious about Kepler, you can watch a crash course I made a few months ago on my channel. So feel free to go and look at that. So now here I'm going to create a constant. I'm going to call it k and pass and call actually the init Kepler function, which will return the context. Create it and return it and store it in the k constant. And then here I'm going to first load my various sprites. So let's first load our background image. So the way you load an image in Kepler or a sprite, you give it a name as the first key. The second key is the path. So here our path is going to be in the public folder, and then the background.png. And something with Vite is that you don't have to specify public. It's automatically going to know what it is. So you can just do // and then the name immediately, background.png. If you had a folder within the public folder, you would have to specify it. For example, sprites / background, etc. I hope you understood that. Okay, so now I'm going to have another load sprite, and it's going to be our character sprite sheet, and we need to extract from it all of our various animations. So I'm just going to close this and do something like that. So // oops. I think you could even get away with just putting the name of the image directly. And then when you load a sprite sheet, you can optionally have a third param, which is an object that is going to you're going to configure how you want Kepler to divide your image into individual frames. So if I look at my characters.png file, you can see that we have 2 rows of 9 images, I think. So here I'm going to specify the slice y property to being 2. So slice y is how many rows per column? Yeah, how many rows per column? And slice x is how many columns per row. So one is in the y-axis, the other the x-axis. Well, actually, it's not very clear. Actually, there's 8. I think there's 1, 2, 3, 4, 5, 6, 7, 8. 8 sprites. So here we go. So usually slice y is this slice. Oh, okay. So slice y is how many frames do you have per column? It makes more sense like that. How many frames per column do you have? And slice x is how many frames per row you have. That way it is much more straightforward. Yeah. Now you have a third property to define here called the anims, and it's where you're going to define all the animations. I do not want to type them all manually, so I'm going to copy and paste them here. So here, these are arbitrary names, and you have two options. If your animation is only one frame, you can just specify the frame number. How do I figure this out? Well, in the character.png, since we told Kplay that it's going to divide the characters sprite sheet using this, so 2 frames per column and 8 frames per row, that means we have all of our individual frames sliced, and the way a number is assigned to each is by the top left corner. It starts with 0, so this is frame 0, then 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, and 15. Since we only have one frame we want for this down idle animation, which I decided on the name, you can decide an arbitrary name, it's up to you, then it's only going to refer to this frame. And then for animations with more, you specify an object with the beginning frame and the last frame of that animation. So the first frame of that animation is frame number 4, and it's 0, 1, 2, 3, 4. So it's this one, and then 4, 5, 6, and then 4, 5. So it's a 2-frame animation here. So frame number 4 and frame number 5. And then here the loop property is something you can define if you want to have your animation loop indefinitely until it is stopped by your own logic, your code. And that's it. That's the logic. Feel free to copy and paste that. By the way, the source code is also going to be available in the description. All right, now let's create our background. So still within the function, I'm going to just create the background, and then once the background, so we have our background image. So our background image, just to show you, is this one. So here in init game, I'm going to go here, create a game object. So the way Kplay works is with game objects. Game objects are created by using calling the add method function of the Kplay library. So by doing k dot, you have access to all Kplay methods, and by using the add method, you can create a game object. A game object is created by passing to it an array of components. Those components are offered by Kplay, and they come with handy behaviors. For example, you can use the sprite component if you want to display a sprite for that game object, and you pass in the name of that sprite, which is defined here. And you can also use the positional component, so k.pos, and specify the coordinates you want to place your game object. And then finally, you can also use, for example, the scale component if you want to scale the image. Here I want to scale it 8 times. So all of these components are offered by Kplay, and if you look at the official Kplay website called kplayjs.com, you can find the documentation and see a bunch of other components you can use. By the way, I have plenty of tutorials using Kplay, so if you want, you can just watch some of them and have a better understanding. So now let's check if everything is all right. So I'm going to go to the main.jsx file, and it's actually where here we're gonna call the init game function. So maybe at the end, after having created our React UI. So by the way React works is you have a create root function that you call, which is basically what creates your React UI and inserts it within the div you specify. Not necessarily a div, but within the root component. And that's why here you specify that we want the here it shouldn't be root, it should be UI. So we want to place everything we render here inside of our div here. And here the reason it's using strict mode is something offered by React that allows you to catch errors, etc. One thing that it does, it runs twice your app. For example, use effects, which is a hook, React hook, will run twice instead of once, only in dev mode. So this is something used to catch errors and etc. And then here it's app. It's the component. So by the way, one thing I forgot to explain in React is that when you create your React component, the way you use it elsewhere is now you have the ability to use it as if it were an HTML element, like it's a GSX element. So here, instead of import app, it's actually React UI. Since I changed the name, it wasn't initially app. And here you can pass it as React UI, like that. And finally, you can also import the index.css like this using an import statement. So it imports this file here. We're going to later on write some crucial CSS that allows us to have our React-based UI always scale accordingly and be in the right position along with the canvas, because remember, our canvas can now also scale using the letterbox option of Kplay. So here I'm going to call init game here, and it should import it from our init-game.js file. So let's run our project for once. npm run dev. Here we go. And now we have a working project. Let me open up the console, increase the font size, and here we go. We have something. So by the way, if you press F1, which is the debug key or the debug key you specified, you can see the FPS counter. And it's also here where you can see a hitbox, for example, the hitbox of the various game objects you create, depending on if you use the area component. So now let's continue on and write a bunch of logic just to have a working game. So for our player, movement, and the other character, and that's it. We're not going to have the collisions for the map, etc. This is out of the scope of this tutorial. We're really focusing on having a layer, basically demonstrating how you can use React with Kplay or with the HTML canvas game to have this back and forth between the two. All right. So now I'm going to go back to our Kplay init-game.js, and let's create our player component. Our player game object, sorry. So the player game object is our player logic, and the way we're going to do this is I'm going to create a constant called player, where I'm going to hold the game object created by using the add function. Here we didn't do it here because we don't need the reference, but later on we're going to need the reference for the player, because once you create a game object, it has access to a bunch of methods depending on which components you pass, and those methods can be handy because for your game. It's going to be clear in an instance, sorry. So here I'm going to use the first component, which is the sprite component, because I want to display the character. So I'm going to type in the names of the sprite sheet, which is characters here. But I want a specific animation, so you can optionally pass as a second param to the sprite component an object and specify the default animation. And the default animation is down idle, which is what I want. Now if I look, is it here? Yeah, down idle. Now the other component we're going to use, again offered by Kplay, is the area component, not the ear component, area component. And what it does is create a hitbox for your game object. So automatically a hitbox is going to be very, very useful, because you're going to be able to, listen on collisions, you have collision detection, etc. So now I'm going to have a body component, which allows our game object to be subject to physics, etc., which is useful for having actual collisions with walls, etc. So I'm just going to use that as well. The anchor component allows us to draw the game object from the center. By default, things are drawn from the top left corner of their origin, which is a default behavior in many game making libraries. But for this project, I thought it would be more intuitive to have the sprite drawn from the center so that everything is very simple. Finally, I'm going to scale the game object by 8 times so it fits. So there is a reason why I do this. So I created my game as a 1920 by 1080 p screen resolution. I could have decided on a smaller resolution, but when you do this, there's a bunch of bugs, visual bugs, visual artifacts. That's why I was forced to actually upscale the resolution. Because if you were actually making a retro-inspired game, you would use a smaller resolution and let the layer box scaling scale the game. But because of something specific in Caplay where there's visual bugs and the debug menu doesn't work well because everything is too big, and anyway, it's hard to explain. That's why I opted for this. So now that we have our scaling here, we can add a tag. So a tag in Caplay is very useful because it can identify in on collision logic. So you can identify in on collision handlers the player you want, the game object you want to listen on regarding the collisions, and by placing a tag, it makes it very easy to do so. So it's going to be clear, but a tag in Caplay is just passing a string to your array of components when you create a game object. You can also pass in an object, a JavaScript object, to the array of components, array that you pass to add, and it can be used to create custom properties. So think of it as like in object-oriented programming where you can create properties, so private variables, etc. I'm going to create one for the speed, and you're going to be able to access it from the player by doing player.speed. So these are custom. And I'm going to also have the direction, a direction property I'm going to use. I'm going to use a vector2, which is a data structured offered by Caplay, where you can specify the coordinates. So you can specify two values, and it makes it very handy to work with x and y coordinates because it offers a bunch of methods for comparison, for example, checking if two vectors are equal, etc. So here we set it up to 0. It's going to be useful in our movement logic in a moment. I'm going to have an onUpdate loop. So you create this by using the onUpdate method and passing it a function. What this does, it's going to run the function you pass in it every frame, so 60 times per second if you have an FPS of 60 FPS. So if you have 60 FPS. And it is on update of the player because if the player gets destroyed or is no longer in the game, this will stop running. So it's more performant than simply doing k.onUpdate, which is possible, but this onUpdate is a global update loop. So something to think about. Really prefer to always use this if you can get away with it. So here I'm going to first set up the direction. So since direction is a vector2, we can access the x coordinate by doing .x, and we set this to 0 initially at the beginning of each loop. The reason we're doing this is because then we can set it up depending on which keys are being pressed, and this is how we're going to implement player movement. The reason I want to implement this, even though it's not the ultimate purpose of this tutorial, is just like to be more comprehensive, so it's not in a vacuum, you know. So we can have a working example. So here I'm going to copy and paste the logic here, and I'm going to explain. So here you have the isKeyDown function method offered by Caplay, which you pass in the key, left, right, up, and down keys, which are specified by Caplay by default. So by calling this, you're basically asking if the left key is down, and if it is the case, we're going to set the direction vector, the direction x coordinate to -1. That means we're moving to the left, to 1, and the x coordinate if we're moving to the right, -1 if we're moving in the y coordinate, -1 if we're moving up, and 1 if we're moving down. The reason it's -1 is because in game development and game making libraries in general, the higher the value of y, the lower you get on the screen because the coordinate system is inverted. So the y-axis goes down instead of going up. So it's something tricky if you're not used to it, but in game dev it's pretty much a convention. So you're going to see it in many other libraries. So now we're going to have our first if statement. Here again, I'm going to copy the code and talk over it just to not spend too much time on it. So our first if statement is the following. We're going to check if the direction vector is equal. So equal EQ is a method offered by Kplay on vector2s. So vector2 has this method. That's why direction is a vector2, because we created it using the vector2 method from Kplay. That means we can use the EQ so to check equality with another vector. And here we create another vector with -1, 0. By doing this, we're able to, in a handy like syntax, compare. So if you didn't have access to this, you would have to do player.direction.x equal -1 and player.direction.y equal 0 and player.getCurrentAnim.name is not left. So here what we're doing is this. So if we get the current animation and its name, and if it's the name of the current playing animation is not equal to left, we play the left animation. Since this method, this onUpdate method, runs every frame, so the function we pass to this method, then what this means is that the next frame, if we are still pressing, let's say, the left key, and we already are playing the left animation, makes no sense to play it again. It's going to interrupt the animation and start it from the start again, and we don't want that. And since our animations are by default looping, because we set the loop to being true, then we don't want that because it's already looping, and we don't want to overwrite this, replay the animation. It's going to restart from frame 1, and we're not going to get this nice walk cycle. So here again, the same logic applies for the other directions. So here for the right key, for the right animation, sorry, here is for the up key, and I mean the up animation, and now for the down animation. And now it's time to write the logic to set the animation back to idle. Let's say the player has stopped pressing the key and we want to go back to the idle animation. The way we're going to do this is with this neat little trick. So it's it's an if statement. What we do here is we first check that neither the x and y coordinates of the direction vector is not 0. So we check that it is equal to 0 on both axes, so that we know that there is no movement. We check also that the name of the current animation doesn't include the idle name. And if it's the case, then we play the current animation dash idle. So this is a trick I used because, here I have my anims defined as the following. So down idle, up idle, right idle, left idle. So there's different idle animations. So if you were already in the right animation, it was already playing, and you stop pressing any keys, the last if statement that I had below will check that, make sure that there is no idle in the name of that animation, and if that's the case, we're going to add a dash idle so that it is going to play this animation, this idle animation. That way we can have the proper idle animation depending on what was moved or played before. And then finally, for the movement code, this is something that is a bit mathematical. So here we go. So here we have a diagonal factor constant. Let's define it above. So let's say right below here, I'm going to create a constant called diagonal factor, and it's going to be 1 slash, so 1, 2, math, so the square root. The reason for this is because the when you move diagonally, if by default you just don't do anything, your logic will not work properly because diagonally your character is going to move faster. I'm going to explain this why in an instant. So it's not the focus of this tutorial. I've written a blog post on it on my Substack. By the way, my Substack is where I post written tutorials. So here, how to display an HTML-based UI on the top of a JavaScript canvas. Or here you can have a bunch of, I recommend that you subscribe so you cannot miss out on posts like these, which are self-contained, etc. So here's the mathematical reason. So give this a read, and you're gonna find out why it's better to make sure that in diagonal you multiply by the diagonal factor, which is 1 to the square 2, and this is usually how much longer so really here we can deduce that any diagonal is always a factor square 2 longer than the horizontal and vertical direction. So here there's a full blog post I've written to explain why. It's not the focus of this tutorial. So just to explain the if statement here, we check if the direction y and the direction x and direction y are true in a sense by using this boolean. That means that both of them are not 0. So that means you're pressing both. So it's either 1 or -1, etc. So in that case, we know that you're moving diagonally, and because you're moving diagonally, we can use player.move. So by the way, because we used the body component when defining our player game object, we can use the move method. I think you can use the move method even by default without having to use the body component. But the move method takes in basically the vector. So a vector, and that vector defines the direction to move your player and also the speed. So depending on the values in each of the members of that vector. So here player.direction.scale is going to scale our direction vector according to the diagonal factor multiplied by the player speed. So the player speed, we set it up to being I think 300 or 800. And as I said, the way you access it is by doing player.speed. All right. Now that we have that, in that specific case where you do this, then you return early because you don't want to run this logic, which is the other cases where you're only moving in either one of the directions. You just call the move function and pass your vector, your direction vector, which contains either ones and zeros or -1s, etc. You scale it according to the player speed, so that it's going to be like -800 or 800 0, etc. By scaling, it's going to move by that amount. So hope that was clear. All right, so now that we have that logic, let's try it out. Let's look at the result. So here I have my character. Actually, this is the final product. So here, this pause is undefined. And why is that? This pause is undefined. Okay, I made a mistake. Probably forgot the positional component. I think that's it, yeah. So in our player, in our player here, I forgot to add a component called the positional component. And here you can use something called k.center, which is the center method, returns a vector 2 that represents the coordinates of the center of the canvas. So that way, if you just want to place an object at the center, you can just call that and pass it to the positional component. So now if I look at the result, I can have my character here, and I can move even diagonally, and it should work. Even though we don't have 8 directional animations, it's going to know that to just pick the left or the right, depending on which one you press first. So do this. So if you press up first and then you move diagonally, it's going to just use the up animation. And if you press left first and then use if you press right or left and then add in the up or down, it's going to use it's going to remain using the left or right animations. All right, now that we have that, it's time to continue our logic, and for the NPC, place the NPC, and then once we have placed the NPC, we can finally move on to writing our React code and Jotai and linking it up with Jotai. Well, first we're going to write the React code and then link it up with Jotai. So here I'm going to create our NPC game object in the same fashion. So an array of components, and you know what? I'm just going to copy the code for it and just go over it. So here again, we use the sprite component. We display the characters using the default NPC left animation we defined earlier on. Use the array component, and here in the body component, you can pass in optionally an object with the is static property set to true. This will make the game object act as a wall, as an obstacle that will not move if collided with. So that is usually a property you use when you want the player not to be able to push something. So if you want to make a Sokoban game where you push boxes, then you shouldn't use that. You shouldn't, because you want the player to be able to push your game objects, your boxes here, if let's say the NPC was a box. And then here the position, this is what felt good, looked good, and that's it. That's pretty much it. And now if I look at the result, so if I go, you can see that the character is placed in the correct position. All right, now I'm going to have a onCollide. So now that we have used the area component, we have access to the onCollide method. So because we have the reference to the game object, and what it takes, this onCollide method as the first param is the tag of the second game object you want to check collisions with. And this is very important because it's the whole reason we added the player tag here, so that we could identify this collision. So by doing this, it's going to run whatever you pass as the second param, which is a function. And here, since you pass in the tag, it's also going to provide to your function as the first param of that function the game object. So here you can create a param that will receive that game object. So you could have named it whatever you'd like. So you could have named it name or whatever, but it's going to give you the game object. That's why I named it player. Now in this particular case, you wouldn't need to do that because you have access to the player constant in the same scope, but I'm gonna still use it here just because this is the correct practice in case where you're writing this logic somewhere else in other files and using different scenes, etc. So you can see in my previous tutorials how it looks like. All right, so now I'm going to again have some logic here. So if the player, you know what I'm gonna do for now, let's just go console.log and just write in collided with the player. For now, let's just do that. Let's look at the result. And if I look at the console, you can see the message collided with the player. So what I'm gonna do now is let's write our React code, our Jotai code, and then we're gonna hook it up. So maybe, you know what? I think we should write our Jotai code. So Jotai is going to allow us to create a store, which is where we're gonna store our data. And it's also going to be a way for our data to communicate to pass between the Play layer, the vanilla JavaScript layer, and the React layer. So in store.js, let's set that up immediately. So here I'm going to import two things. I'm going to import atom and I'm going to import create store from Jotai. Then I'm going to explain why. So an atom is the unit, like a state variable in Jotai that you create. So yeah, it's like use state but specific to Jotai. So use state is a hook in React that allows you to create a state variable. Here for Jotai, you create that using an atom, the atom method, atom function, sorry. And the create store is you create our store, a global store, which will allow us to get those atoms and set them as well from both the React layer and the vanilla JavaScript layer. So here I'm going to have an export const, and I'm going to create my first atom, which is going to be is text box visible. So it's an atom that I want to create to check, to set whether or not to display the text box. And here, the way you create an atom, you call the atom and then you pass in the default value you want for that. Here, the default value I want is false. So it's a Boolean. Then the second atom I want to create is just a text box content. So the text itself that I want to display. So I'm going to create text box content atom. And usually the convention is to add atom to the name of your state variable created with atom. And here I'm going to set up to an empty string initially. And then finally, I'm going to create my store, which is what I'm going to be able to use outside of React and within React as well. So you create your store by just calling create store and exporting it. So we're going to see how we're going to use this in an instance. So let's go back to our init game file. And in there, I'm just going to copy and paste the code here. And you're going to see why. So here, you're going to have a bunch of error messages. Sorry. So what I'm going to do is, first of all, I'm going to import my store at the top of the file. Import store. And then it's still, yeah, and then import my text box content atom. Text box content atom. So the way you use Jotai outside of the where you declare the store is the following. So here in my NPC logic, when the player collides with it, we're going to check the direction of the player. Since direction was a property we set in the player game object, we can access to it from the outside by just having the reference to the player. And then here we can check, because it's a vector2, whether or not what is the direction by using vector2s here. And then here, depending on the direction, I'm going to make the character say something different. So when the character, the player, has a direction of 0, -1, that means they're coming from the top. So they're going up, the player is going up. Then we should display the NPC down animation. Since it's a single frame, we don't really need to worry about checking if the animation is not already playing. Anyway, it's just one frame. And here we use store.set, which is the method you use to set an atom from outside of the store.js file. You pass in first the text box content atom, so the atom you want to set. And then the second param is the value you want to give it. And this is the text. Beautiful day, isn't it? And then we do the same thing for the other directions. So here, instead of those beautiful day, isn't it? It's going to be those rocks are heavy. And then here, it's going to be this text box is made with React.js. And this is basically the main one when the player is approaching from the right. And we want to display the NPC facing left. And then finally, here is the water too cold. So these are the values. So, and then finally, we can have another set where this time around we're going to import the is text box visible atom and then set that to true. So what we're doing here is we are first setting the text box content before we make the text box visible by setting the atom related to that. All right, so now that we have everything set up regarding our atoms, let's just look at our results. If I go here, you can see that depending on which direction I come, the character is going to turn around at the opposite of my direction. Now, nothing is happening regarding the text box, and I think that's the time, the perfect time to write the CSS. So the way you're going to go about it is the following. So I have this index.css file, which is going to contain general CSS that is required for our UI to adapt itself and scale correctly, basically, with the canvas that is set with a letterbox option. So how we're gonna go about it is the following. So I'm going to have my CSS reset here. So a CSS reset is something we usually do to set the box sizing to border box, which is more intuitive. Border box means that when you set the width of an element, it's going to also include its padding and margins. While if you use the default box sizing in CSS, it doesn't include those, and that's why it's not intuitive, because when you set the width of an element, it doesn't include in it the padding and margins. So this is something you can do just to have things more intuitive. Now we're going to import our font we're going to use. It's going to be the Game Boy font. It should be here, link in description as well, where to download it. Now here at the root, I'm going to use the root pseudo selector to set up a bunch of CSS variables, the width and the height of our screen, our CSS UI layer. It's going to be the same. It needs to be the same as the one you specified in the init caplay. So be careful with that. And here the font color is similar to what is in my color palette for my pixel art. So I needed to set it up here. Now I'm going to first set up my HTML and body elements to being a width of 100 by 100% by 100% the height as well. So that way everything is, it takes the full length of the screen. I'm going to set also specifically for the body, the position to being relative, the margin being 0. So position relative so that we can place elements within the body where we want them specifically, exactly. So with specific coordinates, something you cannot usually do by default in CSS. You need to specify this as relative for it to be able to, for you to be able to specify those positions by using the top and left attributes later on. And here, this is the crux of the matter, is the selector, the CSS selector for the UI div here, the UI ID. We set the position to being absolute. Actually, relative, I think I explained the contrary. It's for the absolute that you need to have the where you can specify the values as you see fit. You can specify the element wherever you want in the web page by specifying the coordinates of top left. So top could be it's as if it were your x and y coordinates. Here we place them by 50-50 at 50-50%, which means the top left corner of the UI div is going to be at the center of the screen. And then we use the width and height here to specify the width and height of our UI layer by using the CSS variable here, by calling var and then multiplying by the pixels here, and then calculating the value. And then here we use a transform and we translate back. We translate back by -50 by -50. So by default, the div is going to be drawn from the top left corner, but it is centered on the web page. And then by using a translate, we can put that origin that is at the top left and move the div up to the top left corner, which is going to correspond to the width, the location, the exact location of the canvas itself. And we achieve this by using the scale function, CSS function as well, and passing it --scale, which is a CSS variable we have not yet set. That's why we use the default value of 0. This, we're going to set that in JavaScript. You're going to see in an instant. And then here we're going to use the origin transform from the center. We want this to be from the center. The box sizing border box, but actually I already specified it here, so I don't think it's necessary. Here user, we put a z index of 10 so that it is really on top of every other element. User select none so that we can't select like that text, which is weird in a game. It's not a web page. And pointer events to none as well so that the events pass through. So that means when you click on the game, you can actually have the canvas as being active and then you can start playing. So that's why those two are none here. So just to give credit where it's due, I did not come up with this CSS myself. I had to seek help, and I wrote a blog post on this, and the original author is Peter here, and I will link to his socials and GitHub in the credits section of the description. So thank you for providing this CSS, which is really handy. So you're gonna see the impact of it. It's really massive. So now if I go to main.jsx, and here in main.jsx, I'm going to write the logic to set the scale CSS variable you saw, -- scale. So how it works here is we're gonna first, I'm gonna close this. So the goal here is I'm going to first get the UI element by doing, you know what, I should have done this here like that. Paste it here, pass the UI element here, and then I can write a resize observer, which is going to look, so if I'm doing resize observer, which is a JavaScript feature, I pass in a function that is going to run, and here what we're going to do is we're going to have a document. You know what? I'm just going to copy and paste it and talk over it. So, you know what? Let me just copy and paste it. So we're going to go quickly over it. So we have here. We first have document. Here we create this. We set this scale CSS variable by using this method, set property, and then we set the value depending on the offset width and offset height, so of the parent element. So the parent of the UI is the body, and then we divide by the UI width itself to calculate the whichever is the minimum, the scale value. And this is how we achieve this scaling that is similar to the letterbox. And we observe the parent element of the UI. So this is going to run every time we change, every time the parent of the UI element, in this case it's the body, is resized. So here we go. We have our logic here. So now I think we're almost done. Here, one thing I remember I didn't do with Jotai is to actually use it in React. You need to call the provider. So Jotai offers something called a provider, which is a component. You can wrap your other components in it, like that, and then pass to it. So the provider, you can set the store and then pass your store that you created in the store.js file. So here. So this should be imported at the top of the file here. Now, depending on your conventions, you might prefer to put all of your own code here below and all of your external code, like let's say Jotai, at the top here. Just as a convention, but you know, it's not that important for this tutorial. So now that we have our store here, we're ready to create our text box UI component. And here I created this folder called React component. It's not very necessary in the end, but I'm assuming you're going to create more than one component for your UI. But for this tutorial, let's create our textbox.jsx component, and also the CSS file for it. So you can, you know, define your CSS near your React component, which is pretty handy. We are going to create export default function text box. And in there, we're going to return the following. So we're going to return a div for now. And that div is going to have a class name of text box. And then finally, we're just going to pass to it a p tag, which is going to contain our content. And to pass content, you can just have this in brackets. So the way we're going to do this is we're going to have our content, and then we define our content constant above. And then here we're going to use the use atom value, which is a hook that you can use from Jotai that allows you to get the value of a specific atom that you pass in the parentheses here. So it's going to be the text box content atom. And yep, that's it for now. And now, yeah, I think let's just start with that for now. Let's use our text box. So in React UI, I'm going to just pass my text box component. I forgot to import it. Whoops, sorry. So I'm gonna import text box. So now that we have something like that, we are ready to look at the results. Actually, I don't think we're gonna see much. So let's look at the results still. Okay, there's nothing here. Okay, you can see here in small little letters here. So let's add the styling. So I'm going to go back to the textbox.jsx file. In there, I'm going to import my CSS, my textbox.css. So by doing dot imp textbox.css, and in there here, I'm going to just copy and paste the CSS just to go faster. So this is what we're going to do. So we have a class called textbox position relative, so we can place it however we would like on the web page. We specify the top and left corner. Here I'm using pixel values because it's going to scale regardless. So I can afford to use pixel values without worrying about my placement being responsive. So this is one of the advantage of the solution I specified in the CSS. So here the width is set up for the box, the background color being black, overflow hidden, border radius, font family Game Boy, and then for the p tag within, it's going to have the following margins. You could have set it up all of these in one go with margin and then do it, but just to be clear here, it's more straightforward to understand. The font size and then the color being used, and this refers to the font color defined in the index.css file. So I go back here. It's yeah. So I think we're gonna see a difference, and you can see that this text box is made with React.js, and if I go here, it updates the value of our content because now we have hooked our React component text box with the text box content atom using the use atom value. So now we are almost done. The only thing left is to add animations, etc. So the animations, I mean just the text box being appearing gradually, or the opacity going from 0 to 1 gradually, but also being able to close the text box, etc. So let's work on that next. Let's define our first, you know what? Let's first define the following. So is visible, our state variable, and set is visible. And this is going to be from the use atom hook. So use atom is a hook that allows you to again hook into a is a text box, I think. And then use atom, you need to import that as well. So this allows us, the difference between use atom value is you can just read the value, while with use atom, you can also have a setter for that value. And there's also use set atom, but we're not using it in this tutorial, where you can only set the value of an atom. So here it's going to define if our text box is going to be visible. And the way I'm going to go about it is I'm going to set is visible here. So we're gonna only render, so we can do this end. So if this is true, it's going to render this. So this is something you can do in React. So now only if the text box is visible that we can render it. So if I look at the result and maybe refresh the game, if I go here, the text box appears, but now we have no way of closing it. So to close it, what we're gonna do is I'm gonna create a use effect. So a use effect, which is a hook in React. So this is our first React hook that we actually use in this tutorial. So use effect from React, and it's going to run whatever I pass here a number of times depending on the dependencies that I pass as the second param. So here, let me first write my code here. So I'm going to define a function called close handler, which is going to just be a function that will determine whether or not I'm going to close the text box. And here E is going to be the event and is going to contain the key being pressed. So in this specific case, I'm going to first have an if statement that makes sure that is visible is true. Well, actually, we're going to have the reverse statement. That means if it's not true, if it's not visible, then do not run what comes next, just return early. And then here we have an if statement that if the code is space, so this is the key code, is space, then we're going to do some logic to close, so to do. And then here we're going to add this handler to an event listener that we create. So this is something that runs when the component is first, I would say, rendered, and then it's going to also run as many times as the dependencies change. So the dependencies in this case are the is visible state variable. So when this changes, it's going to rerun this. And that's why you need to, when we create our event listener here, we also need to, first of all, we pass our close handler, but first we need to define the event. So let me do that first. So here on key down, or I think it's key press or key down, doesn't matter. On key down, we run the following. Okay, so every time we create an add event listener, we need to provide a cleanup function, because it can happen where the use effect runs more than creates a, how do I say it? There are some cases where you can find yourself, it's a function, by the way, calls a function, that the function, so it can happen when you create a event listener in a use effect, it can happen where it creates more than one add event listener for that same event. That means that you are going to be left with event listeners that are duplicate or that don't are duplicate. So basically, it is best practice to return a cleanup function, which its goal is to just provide with React the ability to remove the same event listener that we provided. So close handler, I might make a video on use effect down the line if I found a way to relate it to game dev. Anyway, so here we go. That's it, and that would be all right. But the reason we cannot just leave it at that is that we want the animation, and this is the final part of the stack, which is using Framer Motion. So Framer Motion is a library for making animations in React. It's very handy. So yeah, this is what we're going to use now. So the way we use it is you import, so let me import it here. You import a object called motion from Framer Motion. And then you, instead of having a div, you do motion dot div. And this will enable us to add animations. And then here I'm going to define our first animation. So here, to go fast, I'm going to first set up an initial value here. So in the class name here as a prop, this is called a prop property. I'm going to have an initial property which define the opacity initially before any animations and the scale of our elements. So it's 0 and 0.5. This would look good. So that when we're going to make the text box bigger and more, how we say, not opaque, but visible, it's going to be a gradual process. So it's very hard to explain like that, but bear with me. So here, outside of the component, I'm going to create variants of our animation. So this is called variants in Framer Motion, which is used to define multiple animations. So I'm going to have the open animation and the closed animation, which is going to set the opacity of 1 to 1 and the scale to 1. And the closed animation is going to set the opacity to 0 and back to 0.5 scale. And here in our motion.div, we can specify another variant. We can first we can set up our variants here, variants. And now here, what is going to happen is you can specify in the animate property. So this is all concepts specific to Framer Motion. For example, here in this case, let's write this out later. Let's first have our transition, which defines the duration of our animation. So you pass in this object and then pass in the duration, let's say 0.2 seconds. And then here I'm going to also have an on animation complete method function that is going to run. I'm going to leave it empty for now as well. So to determine which animation to play, either the one that first makes the text box visible or the second one that close, what we're going to do is we're going to create another state variable. And this is going to be something specific to our component here. So it's going to be a state variable. So is close request, and then set is close request. I want to know if we want to close, if the player wants to close the text box. And here I'm going to use a use state, which is the default way you declare state variables in React. So I'm going to use state here. All right, so is close request and then set is close request. And then here use state, we're going to set this to false initially. And what we're going to do is when we press the space key, we're going to set this state variable is close request to being true. Then we're going to have in our const handle, we're going to create a handle animation complete function that is going to run. And then if is close request is true, then we're going to set the is visible value of the text box, the atom. We can set it here in React, and it's going to impact even outside of React. And then set is close request to back to being false. The reason I'm doing this is the following. So if I just save that, okay, I have an error. Where's my error? Yeah, okay. The reason I'm doing this is that here I'm going to set the is close request, and if it's the case, I'm going to play the closed variant. So close variant of our animation that we defined in the variants array object, and then otherwise it's the open array. And then on animate complete, we run it's on animation complete, handle animation complete, sorry, handle animation complete. And then I need to remove that. All right, so here we go. So what I'm essentially doing this here is I'm making sure that when the player wants to close the text box, we have this state variable that becomes true, and then we play the closed animation. And then once the animation is complete, using the on animation complete prop offered by motion framer motion, we first look at if there was a close request. And if it's true, we set is visible to false. And the reason we're setting is visible to false is because if we set directly is visible to false, it's just gonna not render the text box. So we first wait for the disappearing animation, the close animation to play before actually disabling the rendering of the text box itself. So that's why we use both of these. Is close. That's why the need to use that. All right. However, I think, yeah, because here the reason we have an if statement is that there is the case where we're playing the open animation, and then right after open animation, you might not do anything. So you don't want you don't want to close, you don't want this to run and close the text box because we just ran the open animation. Even if the open animation is finished, that doesn't mean we want to close it. That's why we guard this with an if statement, that it is only when the closed animation is over, which means that is close request is going to be true, that we actually close the text box or disable its rendering by using the set is visible state variable, setting it back to false so that it disappears. And then we set it back to false here for the next time. So now if we check the result, I go, okay, there's an error. Failed to resolve framer motion from does the file exist? Okay, did we import the library? We might have forgotten to import the library. Let's look at our package.json. And we don't have the library, that's why. Okay, I forgot to import it. So I'm going to import the library. Give me a second. So I'm going to open up my terminal. I'm going to Control C and then type in npm install framer motion and then specify at for a specific version so that it works in the future. 11.11.9. Do this. Run npm run dev. And then let's refresh and see if it works. And it does. And now if we do this, and there's an issue. So what's the issue? Window remove listener is not a function. It's remove event listener. So we need to go back to the text box and here remove event listener. So now if I go back, you can see I press the space key and it disappears. I go here, it opens up the text box, I press the space key and it disappears. So this error is just the previous error. And then same thing here and same thing here. And that's it. That's the tutorial. Hope you enjoyed it. If you want more content like that, feel free to subscribe. I just want to mention something. If you go to my channel here, it's written in French, but anyway, I have premium courses that you can access if you become a member of the channel and for a monthly fee. And this is you have access to a JavaScript turn-based RPG battle system course. So the goal of this course was to make a game, an RPG battle system that is reminiscent from old school RPGs with backgrounds that you can see that are reminiscent of the Earthbound games. So if you're interested, feel free to join the channel and become a member. This will help me a lot. I also want to showcase something which is the next premium course. So this is the premium course I'm working on next. It's a 2D developer portfolio. So a developer portfolio as a 2D game, and it works on both mobile and desktop, and it's made with Play and React. So you can have work experience, projects, skill section where you can play around with the various skills. You have the about section with links to each of those. You can close them like that and open the the links. So for example, my Substack, click on yes, and it's going to open up for you. My email, kind of copy it to a clipboard. You can zoom in, zoom out, touch controls made with React. And yeah, so you have, this is just a test. It's not fully complete yet, but that's the project. So just to show you the keyboard controls, if I go here, I can go, for example, here and have fully keyboard navigation. You can move here like that. And yep, that's it. That's the project. And that's the next premium course. So then again, no pressure, but if you want to join, have access to this course. It's not yet out yet. You have the access to the RPG course for now, but this is what's in the works. Thanks for watching, and I hope to see you in another tutorial. Bye.